Cigars are a special case of high-end craftsmanship, shaped through years of slow processing, carried out with extreme precision and control. It is precisely this rigor that elevates their value far beyond the raw materials to the point that a single box has been sold for over $1 million, comparable to limited edition Ferrari models. What creates such value begins in some of the most tightly controlled tobacco-growing regions on the planet, such as Cuba and the Dominican Republic, where climate, soil composition, and harvest cycles are all confined within strict standards. Immediately after harvesting, each leaf enters a prolonged transformation cycle. It is air-cured in darkness for years to slowly release moisture, then subjected to controlled heat to activate natural fermentation within its fibers. Only afterward is it crafted with a rolling structure and burn rhythm engineered to near-perfect precision, so that when lit, its complex layers of flavor unfold in the exact sequence predetermined by design. Today, join Agriculture Insight as we step into the world of cigar fermentation and craftsmanship, and discover how a raw agricultural product becomes the result of a deliberately guided biological and technical process spanning many years. Although they share the same origin in the tobacco plant, cigarettes represent fast consumption, while cigars exist on an entirely different level, one where sophistication is tied to knowledge, and appreciation demands patience and a certain depth of understanding. Unlike cigarettes that can be finished in just 2 minutes, a proper cigar requires several hours to burn. This quiet passage of time guides the aficionado through 3 distinct flavor stages: a gentle opening of wood and dry grass, a richer middle marked by chocolate and spice, and finally a bold, concentrated finish as the essence gathers toward the end of the cigar. The appeal is so compelling that Winston Churchill, the legendary British Prime Minister and one of cigars' most devoted admirers, reportedly smoked up to 250,000 cigars in his lifetime, even lending his name to what is now recognized as a standard cigar size, the Churchill. Once dominating the global cigar landscape, Cuba has long been regarded as the sanctuary of premium cigars, where each handcrafted piece preserves a legacy of tradition. Today, however, the title of the world's largest cigar exporter belongs to the Dominican Republic, producing around 8 billion cigars annually in both machine-made and handmade forms. So which do you prefer? The patient ritual of handmade cigars, or the convenience of modern machine-made options? Every masterpiece begins with its most original essence, and for cigars, that essence lies in the vibrant life within the tobacco plant. In the Dominican Republic, key cultivation areas stretch across thousands of hectares in the Cibao Valley. This region, nourished by 3 major rivers, forms a fertile alluvial basin with an ideal pH balance for growing premium tobacco. Life begins with seeds finer than the tip of a needle, carefully selected and sown into sterile soil trays, then lightly covered with a thin layer of substrate to retain moisture while welcoming the first rays of sunlight. Inside greenhouses, each young sprout is nurtured under a precise nutritional regimen. Temperature and humidity are monitored hourly, ensuring complete protection from external disease. After 4 to 6 weeks, once the seedlings reach 15 to 20 centimeters in height, they are strong enough to be transplanted into open fields. At renowned estates, transplanting remains a purely manual ritual. Each seedling is placed into loosened soil spaced exactly a hand's width apart, a standard distance that allows roots to penetrate deeply while preventing mature leaves from overlapping and competing for nutrients. Although some modern farms have introduced machinery to assist the process, this spacing rule remains unchanged. On large plantations in the Dominican Republic and Nicaragua, farmers still uphold a strict discipline. Planting takes place only at dawn. In those brief early hours, when sunlight is gentle and the soil still holds the night's moisture, Young plants can anchor immediately without thermal shock or dehydration. A simple principle, yet the foundation of million-dollar cigars. Once the tobacco plants have taken root and stabilized in the fields, the most critical phase truly begins, controlling how the plant grows. Over the next 6 to 8 weeks, the goal is no longer to encourage rapid growth, but to direct it with precision. Growers monitor every subtle change, the shift of leaves from pale green to deep green, the elasticity of the stalk, the moisture level in the soil after each irrigation. If growth is too aggressive, the leaves become thin and lack essential oils. If water is insufficient, the leaf structure turns dry and fibrous. Every adjustment is made to achieve balance, a state where the leaves are thick enough, rich enough in oils, and resilient enough to withstand the fermentation process that follows. When the plant reaches about 1.2 to 1.5 meters in height, pale purple flower buds begin to appear at the top. This marks a decisive moment. Before the flowers can bloom, farmers perform topping, a simple yet strategic act. By removing the upper bud, the plant is forced to abandon reproduction and redirect its full energy into leaf development. At the same time, side shoots are pruned away to prevent nutrients from being dispersed. The difference between cigarettes and cigars becomes evident at the harvesting stage. Industrial tobacco is collected by machine to maximize yield, while cigar tobacco is still harvested entirely by hand, slower but more precise, preserving the full integrity of each leaf. The harvest does not take place all at once but extends over more than a month, carried out leaf by leaf from the bottom of the plant upward, following 3 distinct flavor tiers. The lowest tier is volado, accounting for roughly 30% of the cigar's filler structure. These thin, lightweight leaves serve as the combustion base within the cigar. With their lower oil content and porous structure, volado helps maintain a steady burn for up to 120 minutes of smoking. About a week later, the middle tier, viso, is harvested to provide aroma and balance to the flavor profile. This layer forms the body of the cigar, contributing significantly to its overall taste and the complexity that develops during the middle stage of the smoke. Finally comes ligero, the thickest leaves from the top of the plant, typically representing only 10–15% of the total yield. Rich in oils and nicotine due to direct exposure to sunlight, ligero determines the cigar's strength, weight, and its long, lingering finish, defining characteristics of a premium cigar. After harvesting, the tobacco leaves are not sent to industrial dryers, but transported directly to traditional curing barns for natural processing. Here, workers use a needle to pierce through the thick central vein of each leaf, tying them into symmetrical pairs along long strands of twine. These strings of leaves are then hung across wooden beams that run the length of the barn. Depending on the tobacco variety and the intended flavor profile, growers may choose air curing, sun curing, heat curing, or fire curing. This stage is not merely about removing moisture, it is a slow biological transformation. Chlorophyll gradually breaks down while aromatic compounds begin to form. The scent inside the curing barn shifts noticeably over time. In the early days, the air carries a sharp, slightly sour smell of fresh grass. As the process continues, the leaves begin to release a softer, sweeter aroma. The leaves are hung densely from ceiling to floor and left to dry slowly for about 30 to 45 days. During this time, their color changes from green to yellow, eventually settling into a copper-brown tone when properly cured. Experienced workers assess maturity entirely by touch and smell rather than machines. They regulate humidity and airflow by opening and closing the wooden windows along the barn walls. A miscalculation of just a few hours can cause the entire batch to become brittle, moldy, or rotten, resulting in the complete loss of its delicate aroma. Once the tobacco leaves reach the proper level of suppleness, they are stacked into large piles known as pilones. At this stage, the leaves compress under their own weight, triggering natural biochemical reactions that help eliminate harshness, release ammonia, and develop distinctive flavor notes such as earth, wood, and cocoa. Fermentation time is carefully adjusted according to the characteristics of each leaf tier. Thick, oil-rich Ligero leaves may require up to 6 weeks, while thinner leaves, such as Viso and Velado, typically need only 3 to 4 weeks. By the end of this stage, the tobacco loses its raw sharpness, becoming smoother and ready to enter the final phase of refinement. To maintain quality control, workers insert metal probes into the center of each pile to monitor temperature. If it rises above 122 degrees Fahrenheit, the entire stack must be dismantled and turned by hand immediately to release excess heat before being rebuilt. This turning process is repeated 3 to 5 times throughout the fermentation cycle to ensure uniform transformation across every leaf.
At 110, the pilon said that we need to rotate it.
After completing the first fermentation stage, each tobacco leaf has undergone a noticeable transformation in both color and aroma. This marks the moment when master craftsmen begin the manual sorting process to determine the fate of every single leaf. Based on thickness, oil content, and elasticity, the leaves are separated into 3 categories: filler for the core, binder to maintain structure, and wrapper for the outer layer, the leaf chosen for its flawless appearance. Before blending, the central vein must be removed to ensure an even burn and prevent harshness. Since the vein cannot be separated when the leaf is dry, bundles of tobacco are rehydrated in controlled rooms for 12 to 24 hours until they reach the ideal level of pliability. Using skilled hands, workers pull along the length of each leaf to strip the vein manually from base to tip. For wrapper and binder leaves, the vein is removed entirely to create a smooth, unblemished surface. In contrast, filler leaves retain a small, carefully measured portion of the vein to preserve structural integrity and maintain a steady, prolonged burn throughout the cigar. After the initial processing stage, the tobacco leaves move into a quieter phase, one that directly determines the final caliber of the product: aging. At this point, bundles of leaves are carefully arranged in dedicated aging rooms, where time becomes the most valuable ingredient in eliminating any remaining harshness and residual ammonia. Some premium wrapper leaves may undergo up to 10 years of quiet maturation before they are deemed ready for use. To preserve full traceability, each bundle is meticulously labeled with details such as the tobacco variety, its position on the plant, and the date the aging cycle began. Once the flavor reaches full maturity, the leaves enter the blending stage to create a perfectly balanced symphony of aromas. This is where master blenders carry out their most critical task: combining different types of leaves so they complement one another according to a closely guarded formula. The secret lies in the precise proportions: how much Ligero to provide strength, how much Viso to balance the aroma, and how much Velado to ensure a steady burn. Some leaves are selected to maintain combustion, others to define the dominant aroma, while the rest add depth and warmth to the finish. The most experienced experts can assess subtle differences in quality through nothing more than a gentle touch of the fingertips or the scent released into the air. At last, all the waiting and accumulated craftsmanship converge at the rolling table, where loose leaves are given a soul by the hands of an artisan, becoming premium cigars. Not everyone is qualified to stand at this station. Only master rollers, typically ranked from grade 7 to grade 9, with at least 10 to 20 years of disciplined practice, possess the refined touch capable of replacing even the most precise measuring instruments. These torcedores rely on instinct and tactile sensitivity honed over decades. The process begins with the core, where filler leaves are carefully layered and rolled into a calculated loose spiral. This technique creates microscopic air channels running through the body of the cigar. If rolled too tightly, the draw becomes restricted. Too loosely, and the cigar burns hot and fast, destroying the complexity of flavor. A resilient binder leaf is then wrapped around the core to secure the structure before the cigar is placed into a wooden mold to ensure perfect uniformity in size and shape. The true turning point lies in the final wrapper. Using a crescent-shaped blade, the artisan trims the wrapper into a smooth, curved strip, then stretches it precisely before wrapping it around the cigar's body. This tension conceals seams and veins, creating a surface as smooth as leather. A hallmark of high-end cigars. In the final touch, a single drop of natural vegetable glue seals the cap, preserving structural purity. A properly handmade cigar should feel firm yet resilient, like dense foam, and hold a long ash without crumbling. An artisan typically rolls only 100 to 150 cigars per day to maintain consistent quality. Though it may take just 2 to 5 minutes to complete one cigar, achieving millimeter-level precision requires a lifetime devoted to the craft. Once completed, a cigar cannot be packaged immediately after leaving the rolling table. It must first pass through a rigorous quality control process to ensure perfection in both appearance and structure. Inspectors rotate each cigar under strong lighting to confirm that the wrapper is evenly colored, free of tears or wrinkles. They gently press along the body to assess firmness, making sure the filler is evenly distributed with no soft spots and no excessive tightness that could restrict airflow during smoking. Those that meet the standard are transferred to a resting room for an additional 4 to 12 weeks, allowing the different leaves to marry and the flavors to reach full balance. Among packaging options such as paper or synthetic materials, Spanish cedar is preferred for its strict biological preservation qualities. Its unique fiber structure allows the cigar to breathe, naturally stabilizes humidity at around 65 to 70%, and prevents cigar beetle infestation without altering the cigar's natural aroma. Finally, each box is sealed and accompanied by a certificate detailing the batch number, harvest year, and the name of the master roller to ensure full traceability. As you can see, a $1 million price tag does not pay merely for dried leaves, but for millimeter-level precision in airflow and years of meticulous biological control. However, it is important not to assume that cigars are less harmful than cigarettes. In fact, the nicotine content in a single cigar can be 10 to 20 times higher than that of a regular cigarette. Even without inhaling deeply, toxins can still be absorbed through the lining of the mouth, increasing the risk of addiction and serious diseases affecting the throat and respiratory system. Cigar appreciation, therefore, is not about seeking a safer alternative, but about experiencing a flavor, a rhythm, and a ritual that conventional cigarettes do not offer. Yet, this is but a single brushstroke in the grand portrait of Champagne. Now, let us take you to the very first stop, the vineyards at harvest season, where every legendary bottle of sparkling wine begins its journey. One of the key reasons behind Champagne's timeless value lies in its grapes. Among the hundreds of wine grape varieties across the world, only Chardonnay and Pinot Noir stand out as the most suitable candidates, providing the acidity, purity, and depth of flavor essential to this sparkling wine. And remarkably, even when these same grapes are grown in Burgundy, Bordeaux, or California, they can never replicate the true taste of Champagne. Only the region's distinctive chalky soils impart that unique minerality, freshness, and balance. In other words, nature itself has appointed Champagne as the birthplace of this legendary sparkling wine. But even the finest grapes are not enough. Across tens of thousands of hectares, every single Champagne must be harvested entirely by hand. This is not merely a regulation, but a sacred ritual. The official start of harvest can only be declared by a technical committee, after closely monitoring physiological ripeness, sugar levels, acidity, seed and skin condition, and the taste of the pulp. Only when all these factors reach the perfect balance is each village granted permission to begin picking. From the break of dawn, hundreds of workers spread across the vineyards. With sharp, specialized shears, they carefully snip each cluster as though handling a treasure, placing it gently into shallow wooden crates to avoid crushing. To qualify, the grapes must be intact, neither bruised nor wilted, selected right in the vineyard through the keen eyes and seasoned hands of experienced pickers. Immediately afterward, each crate is labeled with the vintage, vineyard name, and exact origin, ensuring absolute transparency and traceability. Unlike red wine, where grapes are typically crushed and fermented with their skins to extract color and tannins, Champagne begins with absolute purity. Immediately after harvest and sorting, the fresh clusters must be transported to the press house as quickly as possible, keeping the berries intact to prevent oxidation and avoid any bitterness from the seeds or skins. What makes Champagne unique is that the grapes are always pressed whole, in bunches. This long-standing tradition is closely tied to the classic coquard or basket presses, designed to spread the clusters evenly and apply only gentle pressure. Today, many producers have adopted modern pneumatic presses, which allow for more precise pressure control while still honoring the philosophy of pressing, not crushing. This stage is the cornerstone of the Champagne method, pressing with utmost delicacy to obtain the clearest, purest juice, pure enough to make white wine even from red grapes. It is the very first step, and also the reason why Champagne houses guard their pressing techniques as a vital trade secret. After pressing, the grape must undergo clarification for at least 12 to 24 hours. Winemakers may choose oak barrels, which add richness, subtle notes of butter and vanilla, and a rounded structure, particularly favored in prestigious vintage champagnes. For non-vintage cuvées, however, the juice is usually kept in stainless steel tanks to preserve freshness, purity, and the wine's characteristic fruitiness. This settling process allows solid particles, soil residues, and grape skin fragments to sink to the bottom, leaving behind a crystal-clear juice, an essential preparation before fermentation begins. The first fermentation takes place much like that of still wine. Natural or added yeasts convert sugar into alcohol and CO2. Since the process occurs in open vessels, the CO2 escapes, leaving behind a young wine with an alcohol content of around 11%. At this stage, it is not yet champagne, but merely the base wine, the overture before the grand symphony that is yet to come. If champagne were a symphony, blending would be its most crucial act of harmony. After the first fermentation, each vat of base wine carries its own character and flavor, shaped by the grape variety, the vintage, the terroir, and the method of maturation. The task of the cellar master, the maestro of the cellar, is to taste hundreds of these different base wines and combine them in perfect proportion. This process demands refinement, experience, and an extraordinary memory of taste. The goal, to ensure that every bottle of champagne expresses the house's signature style, no matter whether the year's weather was generous or unforgiving. Once blended, the base wine is transferred into special glass bottles and swiftly sealed with a steel cap, much like a beer bottle. It is here that the magic begins. The yeast starts consuming the added sugar, producing alcohol and CO2. This time, however, with the bottle tightly sealed, the gas cannot escape. It dissolves into the liquid, creating the signature effervescence of champagne. Beyond the bubbles, this second fermentation also generates lees, spent yeast cells that, as they break down, release complex organic compounds. These impart aromas of toasted bread, roasted nuts, and baked butter. Layers of flavor found only in truly fine champagne. By law, non-vintage champagne must rest in the cellar for at least 15 months, while vintage champagne requires a minimum of 3 years. In practice, many producers age their wines far longer, 5, 7, even 10 years, unlocking greater depth and complexity. After sufficient aging, the bottles of champagne enter the riddling or remuage stage. This traditional technique is designed to collect all the lees into the neck of the bottle. The riddler places the bottles on a wooden rack with angled holes, called a pupitre, and gently rotates each bottle a quarter turn every day while gradually increasing its tilt. Over the course of several weeks, the sediment slowly settles into the neck near the cap. Today, many champagne houses use gyropalettes, automated rotating machines to save time and labor. Yet in prestigious cellars, the art of hand riddling is still preserved, honored as a symbol of tradition. Riddling is a crucial step in preparing the bottles for the next stage, degorgement, the removal of the sediment. This is the magical moment. The neck of the bottle, where the lees have collected, is plunged into a deep freezing solution, solidifying the sediment into a small ice plug. When the cap is removed, the pressure of the CO2 forcefully ejects the plug, carrying the lees out with it. The result is a crystal clear champagne, pure and brilliant, though now slightly reduced in volume. To restore the lost liquid, the winemaker adds a mixture known as liqueur d'expédition, composed of base wine and a precise amount of sugar. This final touch defines the champagne's style: brut nature, extra brut, brut, sec, demi-sec, or doux. The level of sugar determines the taste profile, offering different sensory experiences for every connoisseur. At the same time, the artistry behind crafting the cork and wire cage, the silent gatekeepers of champagne, is equally vital. Unlike ordinary wine corks, a champagne cork is composed of several layers of natural oak bark, strong enough to withstand pressure 3 times greater than that inside a car tire. The wire cage, or muselet, serves as a suit of armor, fastening the cork securely and preventing it from bursting out under the force of the gas. Together, this duo has become an enduring symbol of champagne, steadfast and reliable, yet irresistibly enchanting the moment they are released, marking the opening of a celebration and the beginning of joy. And when everything is complete, each bottle of champagne is sealed with a cork and secured by its wire cage. This iconic image has become inseparable from champagne itself, a universal symbol of celebration and festivity around the world. The bottles are then left to rest for several more months in the cellar, allowing the flavors to harmonize and stabilize. At last, as they emerge from the darkness into the light, champagne is ready to carry within it the legacy of years of meticulous craftsmanship. From the vineyard to the cellar, from years of meticulous aging to the resounding pop of the cork, champagne is not merely a wine, it is the very essence of French artistry, a symbol of luxury and celebration. Every bubble carries the resonance of tradition, the precision of craftsmanship, and the promise of unforgettable moments. To open a bottle of champagne is not simply to drink, but to partake in an eternal ritual of elegance. Every year from August to September, as the crisp autumn winds begin to sweep in, the vast hop fields of the Yakima Valley in Washington burst into a bustling harvest season. This is the golden moment for picking hops, when the cones have reached peak ripeness, packed with essential oils and lupulin, the very compounds that define beer's signature flavor and aroma. At some smaller farms, growers still preserve traditional harvesting methods. The hop bines are cut by hand with sharp knives, assisted by mechanical lifts. These lifts allow workers to reach the towering trellises where hop vines can climb up to 6 meters high. Once cut, The binds are either dropped onto waiting trucks below or hauled down manually before being transported to the processing facility. Meanwhile, on large-scale farms, the harvest has been fully mechanized. Automatic bind cutting machines equipped with sharp blades can process hundreds of hop binds in just a few minutes. As the machines move along the hop rows, their cutting arms slice through both the tops and bases of the vines, causing the entire bind to drop onto a conveyor belt or into waiting trucks below. These modern machines are capable of harvesting between 48,000 and 108,000 pounds of hop plants per hour. Thanks to this technology, the hop harvest takes place at remarkable speed, ensuring the crop remains as fresh as possible. After leaving the vast fields, hops are immediately transported to the processing facilities. But before they can become the key ingredient in brewing flavorful beer, they must undergo a meticulous and carefully managed preparation journey. When the trucks loaded with hop binds arrive at the facility, the processing officially begins. The long vines, still covered in cones, are lifted onto automated conveyor systems or mechanical cranes, ready for the separation stage. To accomplish this quickly and efficiently, the plant employs massive machines known as hop picking machines, advanced mechanical systems made up of rotating brushes, rollers, and vibrating conveyors. As the binds move through, mechanical arms hold the stems firmly in place while the brushes sweep across them, gently stripping the hop cones and allowing them to fall below. Immediately after separation, the freshly picked cones are carried onto vibrating conveyors, where high-powered fans blow away loose leaves, small stems, and other lightweight debris. To ensure that only intact hop cones remain, a final screening system provides one more round of filtration before the hops move on to the next stage. Meanwhile, the stripped binds are taken outside to be recycled into fertilizer or livestock feed, a way to make full use of natural resources and minimize waste. After the cleaning process is complete, the hops move into multi-layer kilns to begin the crucial drying stage. Fresh hops contain as much as 75 to 80% moisture, and if not processed immediately, they quickly lose their quality. Inside the kiln, the hops are spread out in a layer about 24 to 36 inches thick on drying screens, while large fans blow hot air at 130 to 150 degrees Fahrenheit through each tier. This process lasts for 8 to 12 hours, with temperature and humidity carefully monitored to ensure the essential oils and natural aromas of the hops are preserved. By the end, the hops are reduced to just 8 to 10% moisture, the ideal level for long-term storage while maintaining peak quality. As soon as they leave the kiln, the hops are still warm and require a final cleaning. While traveling along the conveyor belts, high-powered fans blow away any remaining impurities. Afterward, the dried cones are transferred into cooling rooms kept at 0 to 5 degrees Celsius, where they are stored for several hours to a few days to stabilize their moisture content before packaging. Finally, the dried hop cones are gently moved by loaders into a specialized pressing system. Here, they are tightly compressed into large square bales to save space and maintain stability during transport. These bales are then packed into sacks, weighing between 20 and 100 kilograms, depending on the requirements of processing plants or customers. In addition to being packaged as whole cone hops, a large portion is further processed for pellet production. After being ground into smaller pieces, the hops pass through pelletizing machines, where high pressure compresses them into small, uniformly sized pellets. This process preserves the essential oils and aromas while significantly reducing volume, making storage and transportation far more efficient. Once the packaging step is complete, the hops are transferred to cold storage kept at 32 to 41 degrees Fahrenheit, preserving their freshness and signature aroma. From there, they continue their journey to the brewery, where they are combined with malt, the core ingredient that defines beer's flavor. Inside massive brewing systems, every stage is carried out with near-perfect precision, transforming hops and malt into a drink that has captivated millions. And now, let's move on to the most anticipated part of the journey, uncovering how a Budweiser beer is finally made. As soon as the barley arrives at the brewery, each batch undergoes strict inspection and preliminary cleaning to remove dust and other impurities. Grains that meet the standards then enter the steeping stage, inside massive conical tanks, submerged in cool water and continuously aerated to awaken the life within. The steeping process follows a cycle of soaking, draining, and resting, lasting about 2 days. By the end, the barley reaches an ideal moisture level of 42 to 46%, the threshold that triggers perfect germination. After being steeped in water to absorb sufficient moisture, the barley is transferred to vast germination rooms, where it is spread in an even, thick layer across the floor. Over the course of 4 to 6 days, the grains begin to sprout. Endogenous enzymes are activated, breaking down the endosperm structure and converting starches into simpler, fermentable sugars in preparation for the upcoming mashing stage. When the sprouts reach the desired stage of development, growth is halted by drying in industrial kilns, reducing the moisture content to just 3 to 5%. Budweiser employs a special low-temperature kilning process that preserves the vital enzymatic activity and maintains the pale, almost transparent golden color, the foundation of the American lager style. The malt is then gently milled to break the husk and release the starchy endosperm, while keeping the husk intact to serve as a natural filter for the next stage. The milled malt is combined with gelatinized rice, a signature ingredient that sets Budweiser apart. Inside the mash tun, the mixture is gradually heated in specific stages to activate different enzymes. Beta amylase produces a high level of easily fermentable maltose, while alpha amylase generates dextrins, contributing to a subtle sweetness and a smooth, rounded body in the beer. Once the clear wort is collected, it is boiled with hops for 60 to 90 minutes. Hops are added in stages. Early additions extract a stable bitterness, while later additions preserve delicate aromas. This boiling process also sterilizes the wort and defines the balanced flavor, blending the gentle sweetness of malt and rice with the crisp bitterness of hops. After rapid cooling, the wort is pumped into massive fermentation tanks, where Budweiser's signature lager yeast converts the sugars into ethanol and CO2 over the course of 7 days. The young beer is then cold-aged for several weeks at temperatures close to 0 degrees Celsius, allowing the flavor to mature into the rounded, pure, and balanced profile that defines the king of beers. Before we step into the modern packaging line, where millions of Budweiser bottles are completed every day, Let's take a look at the surprising journey of those glass bottles. In fact, it all begins with pure quartz sand, melted at over 1500 degrees Celsius, together with limestone and soda ash to form molten glass. This mixture is then automatically blown and molded into bottles with uniform size and strength. Thanks to strict quality control, each bottle can withstand the internal CO2 pressure while preserving the beer's flavor intact until it reaches the consumer. At last, the beer is filled into glass bottles, aluminum cans, or kegs using an isobaric filling system, ensuring that the dissolved CO2 is perfectly preserved. Once sealed with caps or lids, the products move on to labeling, boxing, and shipment to distribution centers. From there, Budweiser's crisp and refreshing flavor reaches consumers across the globe, completing the meticulous journey that transforms humble barley and rice grains into the king of beers. Today, Indonesia accounts for around 60% of global nutmeg production, making it the most important center of this spice, often referred to as the fiery jewel of the spice world. Nutmeg is one of the very few spices whose harvest timing is determined entirely by the fruit itself. When fully ripe, the outer husk naturally splits open, revealing the nutmeg seed and the bright red, web-like aril wrapped around its core, the only signal that harvesting is allowed. Nutmeg trees can grow up to 15 meters tall, far beyond human reach. When the fruit reaches full ripeness, farmers use long poles fitted with a sickle blade at the tip to hook and pull the stem, causing the fruit to fall to the ground, where it is then quickly collected. Crucially, the harvest window for each fruit lasts only about 24 to 48 hours from the moment the husk begins to split. Any delay beyond that causes quality to decline rapidly. The pressure intensifies during the rainy season, when growers must inspect every tree daily, navigating slick trunks and constant threats from red ants and fire ants. With nutmeg, precision is not an advantage, it is a requirement for survival. After harvesting, the nutmeg fruits are gathered and thoroughly washed to remove soil, sap, and insects clinging to the surface. This seemingly simple step helps reduce the risk of fungal contamination from the outset and prepares the fruit for precise shelling in the subsequent stages. Once cleaned, the nutmeg is completely shelled by hand to extract its most important core, the nutmeg seed. This is the part that contains the highest concentration of essential oils, responsible for the spice's warm, pungent aroma and the depth of its flavor. During this process, the worker must also carefully remove the red aril, known as mace, a delicate, web-like layer that clings tightly to the seed. Mace is a spice in its own right and highly valued, but its fragility makes the task extremely difficult. A momentary lapse in pressure can tear the mace and easily damage the seed beneath. A small crack in the seed can reduce its commercial value by 40%, even though its outward appearance may remain almost unchanged. An intact nutmeg seed can retain its aroma for up to 4 years, while a scratched or damaged seed can lose its fragrance within just a few months. After separation, the two parts of nutmeg follow two different paths. The red aril, or mace, is shade-dried in well-ventilated conditions for several days to preserve its color and aroma. Meanwhile, the nutmeg seeds must be air-dried or gently dried for 4 to 8 weeks until their moisture content drops to a safe level. During this time, the hard shell naturally cracks open and the essential oils fully stabilize. Once the nutmeg seeds meet quality standards, they are gathered and given a final cleaning before entering the stage that ultimately defines their aroma, grinding. Unlike many other spices, nutmeg allows virtually no margin for error. Once temperatures rise above 45 degrees Celsius, key aromatic compounds begin to evaporate rapidly, causing the seeds to lose their fragrance even before they become powder. For this reason, the entire grinding process takes place in a sealed, temperature-controlled environment where speed is deliberately sacrificed in favor of preserving aroma. The seeds are ground through multiple stages until they reach a particle size of just 50 to 70 microns, finer than premium wheat flour, allowing the aroma to disperse evenly from the very first use. The powder is then sieved, quality checked, and hermetically sealed to lock in essential oils and extend its aromatic lifespan. At this point, the journey of nutmeg is nearly complete. From a small fruit in the tropical forest to a refined spice capable of retaining its aroma for years, ready to appear in kitchens anywhere in the world. Known as the second most expensive spice in the world, after saffron, vanilla was once valued at the equivalent of a gold bar per kilogram. Yet vanilla is not merely a spice with an astonishing price tag, it is also a strategic ingredient underpinning the entire global industry of confectionery, beverages, and premium foods. With vanilla, harvesting is not simply about picking pods. It is a harsh race against time, humidity, and even other people. Its high value makes vanilla a constant target for theft, forcing many farms to accept the reality that around 10% of their annual yield disappears each year before the pods ever leave the field. Vanilla reaches peak quality only within a very narrow window of ripeness. Harvesting too early results in weak aroma, while being late by even a single day in humid conditions can cause mold and reduce the pod's value by up to half. For this reason, each vanilla pod is cut entirely by hand using a small knife, requiring speed paired with absolute precision, and is then immediately gathered and transported within the same day to prevent any uncontrolled fermentation from beginning. When the vanilla sacks arrive at the processing facility, they immediately enter a strict security control system. The entire site is surrounded by barbed wire fencing and monitored 24/7 by surveillance cameras to prevent theft. In their raw state, vanilla pods are hard, brittle, and almost entirely odorless. To awaken the latent aroma inside, the pods must undergo a hot water blanching step. This brief but precisely controlled heat treatment softens the pod structure while simultaneously halting natural growth. More importantly, it triggers a chain of enzymatic reactions within the pods, initiating the formation of the characteristic aromatic compounds. Among these compounds, vanillin is the dominant component, accounting for around 90% of vanilla's signature flavor profile. After blanching, the vanilla pods enter the sweating stage, during which they begin to turn a deep brown. This process reduces moisture, concentrates flavor, and allows vanilla's characteristic sweetness to develop. While still warm, the pods are placed into wooden boxes lined with multiple layers of blankets to retain heat for as long as possible. The boxes are then sealed for 48 hours. By the end of this stage, the pods have darkened significantly and are ready to move on to the drying phase. The drying process of vanilla takes place in two stages: sun drying and shade drying. This step is crucial for allowing the pods to fully develop their aroma and rich color. The vanilla pods are spread evenly on cloth and exposed to sunlight for 3 to 5 hours per day over many consecutive days, and are turned frequently to ensure even drying. During this process, skilled workers gently massage the pods to help release essential oils and intensify the aroma. However, the pods cannot be left in the sun all day, as vanilla must retain a certain level of moisture for its flavor to continue developing. After sun drying, the pods are covered and stored overnight, then returned to the sun the following day. After approximately 10 to 15 days of sun drying, the vanilla pods are moved to shade drying in a well-ventilated environment, where they remain for 2 months. After the drying process is complete, vanilla pods undergo strict grading based on length, flexibility, color, and aroma. Pods that meet quality standards are bundled into small groups and tied with twine to preserve their natural shape and prevent cracking during transport. However, not all dried vanilla carries the same value. Across total production, only about 20 to 30% of the highest quality pods are selected for refinement into natural vanilla extract, the most economically valuable product in the vanilla processing chain. The remaining pods are typically sold as dried whole vanilla or used for lower-grade flavoring applications. More striking still, in a global market with enormous demand for vanilla, around 95% of products labeled vanilla contain no real vanilla at all, relying instead on synthetic flavorings. This reality makes each properly cured natural vanilla pod not only rare, but a true concentration of time, craftsmanship, and months of patience.